All right, welcome to our discussion today of limiting reactants. Today we're going to figure out just how to find a limiting reactant in a problem. So let's get started. So we have this situation when we place copper metal into a clear solution of silver nitrate, a bright blue solution starts to form, and all the copper metal gets used up, and turns to copper nitrate. So right here in the equation, so copper nitrate, and this solid silvery metal forms in the bottom, which is just pure silver here. So we have this reaction delivering it out. Now, normally we would say, hey, if I had 25.6 grams of copper, how much silver nitrate would I need? We'd then figure it out. And then we could also use stoichiometry to go, if I had 25.6 grams of copper, how much silver could I make? How much copper nitrate could I make? Well, here is something weird happened. We have not only a certain amount of copper, but also a certain amount of silver nitrate that's there. Now, it's possible that this amount of copper is just the perfect amount to just perfectly use up this amount of silver nitrate. But that is super hard to imagine that's going to be the case if you just randomly start with two things. So the first thing to do is we have to figure out which of these two things is going to actually be the one that runs out. Because this reaction will stop either when the copper's all gone or when the silver nitrate's all gone. We need to figure out which one dies first. And that thing that goes out, disappears first, is called the limiting reactant. It's called that because it limits the production of products. It limits the reaction by turning it off once it's all gone. Now this process might be a little bit tricky seeming. Let's go to the next slide and see how to do it. There's a two-step process for it. So again, all I've done here is gotten rid of that description at the top, and we have the same balanced equation right here. And we have the same numbers, 25.6 grams and 13.6 grams of silver nitrate. So step one says, start with one of these two reactants. Doesn't matter which one you start with. And then figure out, so say for example, we're going to start with this reactant. And we'll say, okay, so let's start with 25.6 grams of copper. We need to figure out if we have this much copper, how much silver nitrate will we need to use it all up? And then we compare how much we need to how much we have and figure out which one runs out first. All right, let's do this thing and see what happens. So just as always, we start with 25.6 grams of copper. And again, you could have started this process with a silver nitrate. It would look the same. I should say it looks similar. Obviously, you would do different stuff here. And I have here, I've already found my molar mass of copper from my periodic table. I need to convert from how heavy to how many. So I'm going to put that 63.55 grams. And again, this number is just coming from the periodic table. Grams of copper is 1 mole. Now at this point, this tells me how many moles of copper are in 25.6 grams of copper. So far, so good. And again, I'm trying to figure out how much silver nitrate I need to use that up to see if I have enough or not. All right. So my next step here is to convert my moles of copper into moles of silver nitrate. So for every 1 mole of copper, I need 2 moles of silver nitrate. Great. So this number right here, so moles of copper cancel. This number right here, if we stop and do the calculation of all 3 of these things together, this would tell me the number of moles of silver nitrate I need in order to use up all 25.6 grams of copper. Okay. Now the next thing, of course, I can't compare it to what I have because I have grams here. I need to convert this number into moles. So on the bottom here, I'm going to have 1 mole of AgNO3. Oh, excuse me. Sorry about that. And I've already found the molar mass of silver nitrate, and it's 169.91 grams. Again, that's silver nitrate. That's just the mass of all of AgNO3 added together from the periodic table. And moles cancel. Now this final number, this is the key thing understanding what this means. This final number we get is going to be the number of grams of silver nitrate that we need in order to use up all 25.6 grams of copper. All right, so to do this math, we start with the 25.6, as always. And the next number is on bottom, so we divide by 63.55. The next number is on top, so we do times 2. And this number's on top, so we do times 169.91. And we need 136 well, we have three numbers, so that's all we really need there. So it ends up being about 137, sorry about that, grams of silver nitrate. So you might say, whoa, that's pretty crazy because I need 137 grams of silver nitrate to use up 25.6 grams of copper. Now, step 2. What we do is we take how much we need. This is what we need to have to use up all of this. Compare it to what we actually have, and then see which runs out first. So I have 13.2 grams of silver nitrate dissolved in the water. In order to use up 25.6 grams of copper, I need 137. Well, I don't have nearly that much. I only have 13.2. So my limiting reactant here is the one that runs out first. Well, I'm going to run out of silver nitrate really fast because I'm going to run out of it after 13.2 grams, and I need 137 to use all of this. So the limiting reactant is equal to silver nitrate. And the way I'm going to write this, it's going to be hard because my pen is starting to die down on me again already, is, so the reasoning for this is I need 137 grams of AgNO3 to use up 25.6 grams of copper. But I only have 13.2 grams. So that means the silver nitrate is going to run out first because I need more than I have. Awesome. Now, if that turned out differently, if this turned out to be like 5.7 grams, then I would need less than I would have. I'd have plenty of silver nitrate. My copper would run out first. So it's just that logic. Once you get to this point, it's just like making it make sense to you. And the key thing and why we've been pushing this understanding the numbers so well with stoichiometry is because understanding the numbers is the only way to do this next stuff. All right. So now a word to the wise. Once you have your limiting reactant, that means that in this case, we're going to use up all 13.2 grams of this. We're not going to use up. This number is garbage to us. We're not going to use that number up. We would never use it again. We only use the mass of our limiting reactant when we find out other stuff. So how much silver we're going to make is based on how much silver nitrate we have, not how much copper we have, because we're not going to use all this copper. At the end of our reaction, there's going to be a chunk of copper sitting in the bottom. Now, it's going to be less than what we started with because some will get consumed in the reaction, but not all of it. Whoops. So now this last question. This last question then asks us, how many grams of silver will we get? Oh, I did it again. Sorry, guys. It asks how many grams of silver we're going to get. So we know we're not going to use the copper. It's not the limiting reactant. We're not going to ever use 25.6 grams. We're going to start here. So 13.2 grams of silver nitrate. And we're just going to use stoichiometry to go from silver nitrate over here to silver. And we see that my silver nitrate is 169.91 grams of silver nitrate, AgNO3, per 1 mole of silver nitrate. And again, I put the grams on the bottom so they cancel, right? So grams and grams cancel. And this tells me how many silver nitrates, how many moles of silver nitrate are in 13.2 grams. The next step is to convert from, for every 2 of these, I get 2 of those. So I have 2 moles AgNO3 and 2 moles of Ag. So that's a 1-to-1 ratio. So those two are going to cancel. So moles of silver nitrate. Now this tells me how many moles of silver I need to, how many moles of silver I will get if I react 13.2 grams of silver nitrate. Again, notice how that language changes because I'm looking for a product. It starts saying things like moles of silver I will get if I use up this much silver nitrate. All right, and the last thing I'm going to do is convert the moles into something measurable, which are grams. And we have here that silver has a mass of, so 1 mole on bottom of silver to cancel the silver, and a mass of 107.9 grams of silver per mole. So this number ends up being my answer here, which is going to be how many grams of silver I can make if I use 13.2 grams of silver nitrate up. So to do the math, I just type in the first number, 13.2. Next number's on bottom, divided by 169.91 times 2 divided by 2. And you might be saying, Mr. Haza, that cancels, doesn't it? And if you notice that, that's totally fine. The 2 and the 2 totally cancel. You could do it that and avoid that. And then our last step is times 107.9 and hit equals. And we have 8.38 grams. 8.38 grams. And the last question we want to ask ourselves, so this is silver, right? So this we can make 8.38 grams of silver if we use up 13.2 grams of silver nitrate. Now let's see if this number makes sense. So these silver atoms are coming out of the silver nitrate and leaving the NO3 behind. So we would expect we would have less mass than what our silver nitrate was because we're basically just plucking just the silver out of silver nitrate. And we started with 13 grams of silver nitrate and we ended with 8.38 grams of silver. That makes sense. It's less than that number. So awesome. Check plus for us. Now the thing to note here, remember, whenever you're finding the mass of a product or reactant, you don't want to use the mass of the limiting reactant. Don't ever use, the non-limiting, the excess reactant. You only want to use the mass of the limiting reactant for any problems after that. All right, best of luck to you. See what you can do on those worksheets. Reason through stuff. Take your time. Help each other. Do a great job. Bye-bye.